Okay, so now we need to, I want to go to the browser and find what's called the TM vignette. Okay, so if you check TM vignette, so we can get this one, Introduction to the TM Package. And maybe download it or say, let's see. Download it. Okay. So this is the main package that we use for text mining in R. If you want to use other things, you can. You can write your own code and so on. But this is a good start anyway. And also, let's again take a look at chapter 7 and review what's here. And if you remember, we're going to be data mining the taglines from movies. So here it is. So we can open that up and check it. So here it is. And this apparently, I didn't try and download something like this, but I guess it's easy to download this from the DMB, whatever it's called, movie database, DMDB maybe. So anyway, and here you can see that there's more than 345,000 rows of data. That I wouldn't say there's not 345,000 records, because each record takes more than one row. But anyway, there's a lot of data here. Okay, now let's look at a little bit of the code. And also, actually, I need to get one more thing. What was that? Okay, so let's take a look at this first of all, the TM package. Okay, so the TM package allows us to work with text data. And it's maintained by this person. And I guess the latest update maybe is this, June 10th, 2014. Okay, so let's read a little bit about it. The main structure for managing documents in TM is a so-called corpus. So we've seen different structures. Can anybody suggest other structures that we've talked about in the past? Other data structures? What other structures have we talked about? We talked about vectors. We talked about, what else? Matrices. We talked about, what else? Data frames. What else? What? Lists. Good. What else? Time series, right? We talked about time series. That's a kind of non-standard one, right? A little bit less standard, right? So somebody added that into R, and it's very convenient. And here's another one called a corpus. And this is good for holding text data. So you store it in a corpus, and then there are different things you can do with it. Or you create a corpus object out of the text, and then you can do different things with it. So that's the standard way that we do everything in R, right? They create a special kind of form, and then you have to import it into that form or create an example of that form, and then you can use a lot of functions on it. So anyway, a so-called corpus representing a collection of text documents. So, okay, a corpus is an abstract concept, and there can exist several implementations in parallel. I guess that means you can have more than I'm not sure what that means, but maybe it means you can, of course you can have more than one corpus at a time. The default implementation is the so-called V corpus, or volatile corpus, which realizes as semantic, which realizes as semantics as known from most R objects. I don't know what that means, but it probably has a little bit to do with linguistics. Corpora are R objects held fully in memory. Okay, so what that means is that when you make a corpora, it's going to be held in memory. So if you have a whole lot of data, you have to have enough memory to store it, right? Because it's going to be stored in memory. Okay? We denote this as volatile, since once the R object is destroyed, the whole corpus is gone. So, it's not stored on the disk anywhere, it's just stored in memory. Such a volatile corpus can be created via the constructor here. So this is how we do it, and we put in our data set here, and then we use this function, and this will create a corpora for us, or a volatile corpora. Now, constructor is just a programming word, which he didn't have to use that here. He could just have said we create a function, we use this function to do it. It just means, creates an example of the object, basically. Another implementation is the P corpus, which implements a permanent corpus semantics. I don't know how he's using this word semantics, but it doesn't matter. I.e., the documents are physically stored outside of R. So in other words, they're stored on the database, in the hard drive, or in a database, or something like that. Corresponding R objects are basically only pointers to external structures, and changes to the underlying corpus are reflected to all R objects associated. So that just means, so if you have several objects which point to the same thing, same items on your hard drive, like we can do that, right? How do we do that? We create a shortcut or something to an object, right? You can do that in Windows, right? You make a shortcut to another object, right? So that means we have several things pointing to the same thing on the hard drive. Then if you change the object on the hard drive, then all those things will reflect that change, okay? Compared to the volatile corpus, the corpus encapsulated by a permanent corpus object is not destroyed if the corresponding R object is released. So I guess it stays on the hard drive. Even if you shut down R, or even delete the object, maybe. Even if you delete the object in R, it still exists on the hard drive, I guess. Within the corpus constructor, X must be a source object, which abstracts the input location. So the X has to point to the actual object that you're trying to make into a corpus, and it has to be the full path to that object. TM provides a set of predefined sources. So if you're pointing to a directory, you'll use this. If you're just creating something from a bunch of items, and then basically you create a vector within your R session, and then you want to import that into a corpora, you use this. If you have a data frame, then you can use this, which handles a directory, a vector interpreting each component as a document, or a data frame like structures like CSV files. Except directory source, which is designed solely for directories on a file system, and vector source, which only accepts character vectors. Most other implemented sources can take connections as inputs. Okay, let's not get too tied down with that. The second argument, reader control of the corpus constructor, has to be a list with named components, reader and language. The first component, reader, constructs a text document from elements delivered by a source. The TM package ships with several readers. I guess we could make our own readers, but there's the read plain, read PDF, read doc. So if you're reading plain text, you would use this one. If you're reading PDF files, you would use this one. And if you're reading documents, you'll use this one. So this is a little confusing, but we'll see some examples of it. See get readers for an up-to-date list of available readers. Each source has a default reader, which can be overridden. So if you have it, it has a default reader, but you can set your own reader. For example, this one, the default just reads in the input files and interprets their content as text. Finally, the second component, language, sets the text language, preferably using ISO code. So what they mean by that is here, we set the language equal to Latin. Okay, and this is the ISO, I guess the ISO 639-2 code for Latin. This is how you express Latin. Okay, so you want to hopefully use that. So I don't know what Japanese would be, but maybe it would be JP, right? You'd use, if the language was Japanese, maybe you'd use JP, but mostly, as far as I understand, most of the tools here are only going to work for English anyway. So I'm not going to really apply to Japanese, but I don't know, maybe there is stuff you could do with Japanese, I'm not sure. In case of permanent corporate, a third argument control, DB control, has to be a list of named components. Okay, so I'm not going to spend too much time on this. So let's try this out, and let's go to R and install the TM package. So why don't you do that? I have RStudio here, but you can do it in R. You just install, if you want, you can just do it like this, right? Okay, I think that works. Okay, if you're using R, you have to choose a location and so on. I guess, or no, maybe you don't have to, I'm not sure. Okay, did that work for everybody or not? Okay, and then we have to, pardon me, we have to do what next? Do the library function, right? Okay, everyone get there? And then let's try some of what he suggests here. So I hope you have this open so you don't have to type it all. So first of all, the system file, what does this do? I forget now. Let's check that system file. Oh, so it finds the names of our system files. And so it finds the name, so let's try that. So let's try this. So I hope you don't have to type that. Have this open. So it's what it's going to, before we do that, sorry. You just installed TM on your, no, not before we do that. Let's do it first so we can actually find it. Okay, so paste this in, like that, and hit enter. And then type txt, and that'll give us the location, you'll see. Okay, so it gives us a location, and that's where these files are stored. So this function, I don't know how it does that, but it finds the location of this here, called txt. I don't know how it did that, but it did it. So I guess it's only works with for files within R. That's why it's so fast. Within the R program files directory. Okay, anyway, let's go to this and see what's there. Let's go to there and see what's in there. Okay, so you can see that when you installed the TM package, it installed these sample files for you. Okay, everyone find this? So you can see where it's located. It's in R3111, library TM texts txt, and there. Okay? So let's just look at this because these are the example files that we're going to use when we read this vignette. So let's just open it up, see what it looks like. Actually, let me open it up in R+ and Notepad++. So it looks like that. Okay, can anybody read this? Nobody? Well, this is not a living language, right? It's not a language that anybody uses now, right? What language is it? It's Latin, right? Can you guess any words here? Because actually English and French and Italian and Spanish all have a lot of Latin influence. So is there any English words or French or Italian or Spanish words that look possibly? Maybe this word might mean people or something like that. Maybe this means legal or something like that. I'm just guessing. Although I did study Latin, none of these look. You can guess what this means, right? Something like artificial, right? Or not. Maybe something like artificial. This is probably somebody's name. And so on. Let's see if there's any more. Let's try one more. Open up this one. You can always put it into Google Translate, right? They do Latin, so you can figure out what it means. Actually, let's do that. Let's put it into Google Translate. Okay, I'm going to put the second one into Google Translate. I think it does. I'm sure it does Latin. Let's see if it can detect the language. Yes. Okay. So, any words we can recognize here? No? How about magnanimity? Magnanimity. No? How about this one? Vulnerus, I think, is wound. Okay, if you're vulnerable, right, you might get wounded. Right? How about this one? Violent, right? You can see it's violent. Violently, okay. Okay, so this is Hector. Hector was, so anyway, this is the poet Ovid, the Latin poet Ovid, and he's writing about Hector, who was Hector? Hector was in the Odyssey, or the Iliad, it was in the Iliad, I think. And so that Hector was destined at his master flogged hands. Yeah, this is Ovid, this is the Iliad, because it's about Achilles. Okay, anyway, sorry about that. But, so let's look at, okay, so anyway, we got this. So we see that there's a bunch of files in there. That's going to be our sample files for this vignette. Okay, now, we use this V corpus here, and what does that do? That was the constructor file. It's going to create a corpus for us. Okay, and what are we going to call this corpus? We're going to call it Ovid. Okay, everyone understand? Is this clear? Okay, and then we have to use the directory source, and that's going to be the txt that we just have here, so that's the location. And then we specify the encoding, which is UTF-8. And then the reader control, he talked about that, has to be a list. And the language we specify as Latin. So let's try and put this in. I guess we have to do this one part at a time. So put that in there. And then put the rest of it in there. Like that. Okay, hopefully you can get that in there. And okay, so that worked, and we put that into Ovid. Now this is a little bit unusual here, the way he does this, because he puts these brackets around here. I didn't understand this at first. He puts this bracket around there and around here, but that's basically, that means printed out. Print, that's the same thing as without the brackets, and then second line would be print Ovid. So if you want to just see that, you can type print Ovid now. Okay, you can see it does the same thing as when he put the brackets around it. So that's like a shortcut for printing the results afterwards. Okay, so he puts this, and there, which basically just says print it. After you store it in here, then print it. Okay, so we printed Ovid. Now Ovid, we use this to create our volatile corpus, and we've stored it in Ovid. So now we have it stored. That's just like when we created an XTS object, right? Or a TS object, time series object, and then we can now work with it. It's called Ovid, just like we could work with time series after we stored them in some time series object. Okay. For simple examples, vector source is quite useful. So if you just have a string, a couple strings, and you want to store them, you can, instead of using directory source, which we just used, you could use vector source. And here's an example of that. Here we have a vector, and he stores it in docs, and then he creates another vcorpus. Where he uses vector source instead of directory source, and there you just have to put that in, the docs in there. Okay? We don't need to do that because we're not going to play with this text here. But if you just had a couple of vectors, you just had a couple strings that were stored in vector, then you could do it this way. Finally, we create a corpus for some Reuters documents as an example for later use. Okay, so now we're going to use the system file. So let's get that one. Let's do this one and find out where these Reuters documents are stored in our computer. So just copy that, put it in here. So this is the path to these so-called Reuters documents. So let's see where that is. So just do that. And these are here. So let's check them and see what they look like. So these came, as I said, as a result of the fact that you installed the TM package. So you got these on your computer. So here are the Reuters documents. So go ahead and make sure you got that. Okay, and let's examine one of these. Let's examine the first one. Let's open it in Notepad++. So these are XML documents. How many people have seen XML documents before? So XML is like HTML. How many people have seen HTML documents? How many people have made a web page? Right? So, you know, if you take any web page, let's take, what's a simple page? I hate this website, but it's a simple page, so I'll use it. So if you take this website, and then you can save it as something on the hard drive, and you can see it's being saved as an HTML document on the desktop. And then if you open it in here, if you open it in Notepad++, this is called an HTML document. This creates that web page. Well, it's pretty complicated, but anyway, it's a big page, so it has a lot of stuff on it. So this is the HTML document. So anyway, we have this one, which is not HTML, it's called XML. And in XML, you can define your own, what are these are called tags. You can define your own tags. So they have a date line and a body, and the company's tag, and exchanges tag, and so on, all these tags. Anyway, this is XML, and this is from a Reuters document, and so you can see it's about oil. The Diamond Shellmark Corporation said that effective today it had cut its contract prices for crude oil. Okay, so it's just some text from Reuters about crude oil prices. Okay, so we have a number of these somewhere here. Okay, so we have these stored here. So this we got from installing the TM package. This is another example. Okay, now going back to here. Now what do we do here? What is this doing? What's the next line going to do? This line here. What's this do? It's going to create another corpus from these documents, from these XML. And what's this one going to be called? Reuters, right? It's going to be called Reuters. So let's just create that because he says he uses that later as an example. So let's do it. We'll create it. You have to do it in you have to copy it in 2 steps, right? Paste, and then the second part. Copy and paste. Okay? And then if you want okay, so what should I do now? What's it say? Mine came out kind of garbled. I don't know why that happened, but what does it say? There's no package called XML. So this is an XML document and it's trying to read it as XML, I guess because of this. So probably because we said the reader is this. So it's trying to use some XML reader, but we don't have the XML package, so what should we do? Install it. So I think it's called that. Yeah. Okay, can you get that? If you do install packages XML, like this, we should be able to install it. Okay? Everyone do that? Install the XML package. Okay, now let's, we have to do what next? Library. I think we have to do library, XML. Library doesn't need the quotation marks, right? library XML. Okay? Does that work for everyone? Now let's try and run that last code before. Again, let's see if it works. Okay, now it works, right? Okay, so Reuters, how can we see what Reuters looks like? We can type print Reuters, or I think we just type Reuters. We just do that, we can see that. Okay, just like we did with Ovid, now we can see this one. Okay? Now, okay, next section in this vignette talks about how to export data. So for the case you have created, in case you have created a corpus via manipulating other R objects, so you have you're working in R and somehow you create a corpus, but it's not on your disk yet. You can export it. Thus do not have the text already stored on the hard drive, and you want to save the text documents to disk, you can simply use the write corpus. So if we didn't have Ovid there, we could create another example of Ovid, or we could create an example of our Ovid on the hard drive, or a file, or a set of files. Okay, just by using the write corpus command. Okay? Okay, now this is more interesting than that, and that is inspecting corpora. So if we want to, so first of all we can type this, inspect Ovid 1, 2. So this is going to allow us to look at the first and second items. You know, Ovid is, I guess, a list. Let's check that. What kind of object is Ovid? How do we check that? How do we find out what kind of object Ovid is? STR. Is it capital O or no? Okay, so let's see what Ovid is. Well, it's kind of big. Okay, so Ovid is a list of 5. And then it looks like they're actually lists of lists. Remember we said you can have a list of lists, right? And this is apparently a list of lists. So it's a list of 5. The 5 are the 5 different, where was that? Here. The 5 are the 5 different text files. Okay, but within the text files, each one of those is actually a list as well. So here's the first one, which is a list of 2 things. So what are the 2 things that each file is a list of? The content, which is characters, and then a meta, which is tells you the author, which in this case it doesn't. There's nothing that indicates what the author was, so that's empty, and the date, time. I think that's all empty. I think this is all empty. Well, the ID somehow, I don't know, this must come from the name of the file. Okay, but the rest of the stuff is empty because it's not set anywhere. Okay, so each of them, each of those 5 in the list is actually a list of 2. Okay, so we have that. All right, everyone get it? Okay, now, let's go to, where next? Okay, so let's try to inspect it. So this is how you inspect it. So if you want to inspect the first 2, you type in inspect, and then Ovid, and then 1 to 2, like that. Okay, like that. Okay, so if you do that, you can see them. Okay, so this is how you can inspect the corpora. Let's try that, see if that works for the Reuters document that we created. So what was the Reuters document? It was called Reuters. So let's try for Reuters and see what we get. So try that. So instead of inspect Ovid, try inspecting Reuters. What do we have to change here? I guess we have to change from Ovid to Reuters. Okay, so we get the first two Reuters objects. So the first one was the Diamond Shamrock report, and then there's another one, OPEC may be forced to meet before a scheduled June session. Okay, everyone get it? Okay, now, let's go back to here. Okay, then you can also look at the metadata. We saw that there's some metadata. In this case, the only metadata is the name of the file. So we could get the name of the file by doing this. So let's read this. Where does this come from? What does this mean? Let's look at that structure again. What did we run? We ran this. Okay, where is this? Okay, where does this come from? What is this doing here? Sorry, this one? What does Ovid 2 brackets and then the number 2 mean? It's the second item in the, remember Ovid is a list, right? Ovid is a list, right? Actually it's a list of lists, right? So what does this mean? It's the second item in the list. And what we're trying to get the metadata. So, and which metadata are we trying to get? The ID. Let's see, is that correct? The second item in the list, the metadata, and it gets the ID. And the ID is this. Okay, does that make sense? Okay, so you could run that, right? Okay. And then there's another function. I guess I don't know what this, when you'd use this, but it's used to check whether things are the same. So you're saying is this, oh, well anyway, in this example, what he shows us is that this, and you can also reference it like this with the ID. Okay, so they're the same, so this is going to be true. Okay, so you can either reference an element in the list with the number 2 here, like this, or you can use the ID name here. Okay? Okay. Now he goes to transformations. Okay, so one thing that we want to do when we're doing text mining is get rid of whitespace. Okay, now let's just check Wikipedia for what a little understanding of whitespace. Super slow. Okay, here's Wikipedia whitespace. Okay, so whitespace is an esoteric. No, that's not what I meant. That's not what I meant. Whitespace characters. Okay, in computer science, whitespace is any character or series of whitespace characters that represent horizontal or vertical space in topography. That's not a very good definition, is it? He says white space is white space. Not too good. When rendered, a white space character does not correspond to a visible mark. So it's characters that you don't actually see. So like, you know, when you hit the return key, there's actually a character at the end of the line, but we don't see it, right? Unless you want to see it. Okay, so spacebar, tabs, enter. I think you can see tabs, but anyway. So these are examples of white space. Okay, so a lot of times we want to remove white space. Now it's not removing the spaces between the words, okay, but other spaces. So we want to eliminate white space. So let's try that here. Now, I think I did this, and I couldn't tell if that there was any difference. But so we already printed out the. Let's just print it out again. Let's do this, just so we have an example to compare with. Let's do this. Oops. Does this work? Yeah. Okay, let's do that. Now let's try to get rid of the white space and see if we can notice any difference. So maybe what I would expect is that this would be eliminated, and it would this "the" would follow directly after the period. Okay, so let's see if that happens. So here's how you eliminate white space. So he creates this, there's this function called tmmap, and he does this a lot. So if you want to apply a white space function to something like Reuters, you do it like this. I don't know, for some reason, I would, the normal way to do this would just say, use this, and then open close bracket with this inside, right? That would be how you, but I don't think that works. Let's just try that. I never tried it. I don't think this works, but let's try it. If you do this, and I don't think this works, but let's see. No, you can't use it that way, or I don't know. Anyway, the way that you run this white space function is by doing tmmap, and like this. So let's try that. So he's going to, actually, but I don't want to do this. I want to save the original Reuters. So let's call this Reuters SW, means strip white space. So do this. Okay, so now I'm going to put this in there. I think this will work. Should work. Okay, now let me try this and see if it looks different. Yeah, okay, it did work. Okay, so it stripped the white space, right? Everyone see that? Did it work for everybody? It stripped the white space. Yeah? Question? Any questions? No? Okay. All right, so we can do that. So that's the one thing that we want to do usually with text mining. Remember, when we do text mining, we're going to use the bag of words approach, right? We talked about that. So we're getting rid of everything anyway, so we may as well get rid of white space, right? Okay, next thing you can do is convert everything to lowercase. Now, why would you want to convert everything to lowercase? Any idea why you do that? Well, just for the exact same reason I just said, the reason why we're getting rid of white space, or the same idea. Because of the bag of words approach, I mean, if you want to consider, let's see, here, let's say, not a good example here, but like for example, at the beginning of every sentence, the first letter has to be a capital, right? And then suppose that same word occurs somewhere else, right? It's not capitalized, right? So do you want to consider those as two separate symbols or the same symbol? If you want to consider them as the same symbol, then you should convert everything to lowercase. Okay? So that's the idea. So how do we convert it to lowercase? So we have to use this. So remember, these are functions as he's written, so he can call them whatever he wants, right? And so he called it this, and you use this to lower, and let's try this one. But I want to change it, the name of it again. I'm going to do this. I'm going to change the name to, first of all, I want to apply it to the SW. So I'm going to do this, SW, and now I'm going to call this one you don't have to do it this way, I guess. SW lower. Okay? We don't, maybe it's not worth doing this, but okay. So now we do that, and now if I print out, if I try this, SW lower, so everything is now lowercase. Okay? Now obviously this is not going to work in Japanese, right? You don't have uppercase and lowercase as far as I know. Okay. So, this is very English specific stuff, right? So maybe there are other packages that work in have been designed for other languages. I'm sure there are a few. But anyway, I guess some of this works for like French and Italian and so on. Okay, let's keep going. Okay, the next thing is stop words. So what are stop words? Let's check this in Wikipedia. Stop words. So stop words, here, list of English stop words. Here's an example. Okay, the stop words. Here, these are called stop words. A, about, above, across. Actually, I'm surprised that above is a stop word. Afterwards, again, all. Okay? These are called stop words. These are words that you may want to remove from text. You don't necessarily want to, but generally, at least some stop words you would like to remove. Like you don't usually want this, you don't usually want this, you don't usually want this. These are not really, these are grammatical words, I guess we could say. And since we're ignoring the grammar anyway, we may as well get rid of them. Okay, so how do we get rid of them? So there are a list of English stop words, and they're called English, and you can use this function to do it. Now I'm just going to go back. I'm going to follow the way he's doing it. So I'm going to do it like this. I'm getting tired of all the extra typing. So I'm going to do Reuters, SWL, but I'm going to do that, but now I'm going to set it to Reuters, so I don't have to keep retyping things afterwards. Okay, like this. And now if I inspect that, now are the stop words we're doing, I don't know, which words? Had. Yeah, had is not there, right? Okay, so we got rid of had, and so on. So what's it look like now? Diamond Shamrock Corporation said, effective today, cut contract price, crude oil, $150 barrel. Reduction brings posted price, West Texas, intermediate, okay? So now it looks like that. Okay, so it's kind of like a bag of words now anyway, right? Okay, now, stemming. Okay, stemming, now this is the one, I guess I tried it and I didn't really see the results, because what I expect for stemming is that falling will be changed to fall. So it gets rid of this ending. And maybe even prices will become just price, so it gets rid of this ending. And for example, companies might become company. Okay, this, and posted might become just post. Okay, so why do we do that? Why would we want to do that? What? Simplify it, yep. And for the same reason I just gave you about lowercase. Right? What did I say about lowercase?
like it'll be easier to search through.
Right, but what did I say about lowercase? I said, do you want, suppose you have a word which is capitalized at the beginning of a sentence, right? Every first word of a sentence has a capital letter, right? And then that same word occurs somewhere else. Do you want to consider them the same or different? So you're trying to count up how many words, like for example, how many times does bomb occur in a text, right? So you want to say the fact that capital B at the beginning, the sentence began with the word bomb, so there's a capital B, and then another time there was the word bomb with a small b. Do you want to say, oh, because it was capital, I won't say it counted for the same as the word bomb? No, right? I don't want to consider those as different, right? So how about here? What am I saying? For example, suppose that, where's the word? We have price and we have prices as two different examples in the text. Do you want to consider those different? Probably not. So if you don't want to consider those as different, then you want to do stemming. If you want to consider them different, then you don't want to do stemming. Okay, so it's up to you whether you want to use it or not, the stemmer, the so-called stemmer. But if you want to, then for example, if price and prices both occur in your text and you want to consider those as the same word, then probably you'd want to do stemming. Now there are different stemmers that you can use. Some of them are so-called more aggressive than others. So, but anyway, this one here didn't seem to make any difference. But let's see. Let's try it. I'll do it. Stem it. Uh-oh. Okay, what happened now? I don't know, why is mine coming up into this? I guess because this operating system is Japanese. Oh, maybe it's this? Is that doing that? Let me try that now. I don't think that's why. No. Anyway, I guess because the underlying operating system here might be Japanese, so it's kind of messing up. Anyway, it's supposed to be called snowball. Okay, so what's it telling me now? What's this telling me? Snowball isn't loaded, right? So what should we do? Okay. And then library. Right? No. What's wrong? I installed it.
Snowball C.
Snowball C?
Yes. That's the name.
But I installed something called Snowball just now.
No, it's called Snowball C.
But it let me, oh, it didn't install, wait. Oh, sorry, you're right, okay. Snowball C? With a small c or capital C?
Capital C.
Capital C,
And
okay.
the capital S at the beginning.
Ah, okay, thank you. So these are, well, anyway. Okay, apparently we need this. Oh, sorry, not that. I need print quotation marks. Okay, maybe this will work. Okay, thank you. Okay, and then I have to do. Like that, I guess. Not really. remember, error and warnings are different, right? Error won't means it didn't work. Warning is some note or something but it still worked. Okay, so now we have that. Okay, now let's try, what was I trying to do? I was trying to do this one here. No. What was I trying to do? Yeah, that's right, that one. Okay, so, let's try it again. Okay, so it supposedly worked. Now let's see what it looks like. I don't know if it looks any different though. No. So it didn't really do much. Like I would have thought this would be post instead of posted, and price instead of prices. So yeah, I don't know. The only thing I can say is that
Backwards.
yeah.
He didn't assign to a new variable, so it didn't work.
Oh really?
Yes.
What do you mean? Wait.
The TM map. It's just a
Ah. Good. Okay. So now. Oh, thank you. Thank you. Well, at least price, but post didn't change. But price changed to, prices changed to price. So that worked, right? So this is not so aggressive because this is still posted. But anything else change?
company.
Company, where's company? Where does it go? Here, this one? Can't read it. If I do this like that, oh, there. Oh, this became company. Okay? So that's what stemming does. So sometimes it makes the words, if it's very aggressive, it makes, but here you can see this. Oh, it's different. So it's very aggressive, it can actually make the words unreadable. Okay? Now sometimes you don't care if it's readable. Like if you're just trying to use it to kind of forecast something else, and you're just treating those as variables. We saw last week that we are going to treat them as variables. And if you're not really concerned with reading what they are, just want to use it for forecasting something else, maybe you don't care that they're readable or not readable. But anyway, it can result in them being unreadable. Okay, everyone follow so far? Okay, now there's some filters. I don't think we need to do that right now, but there's something called filters here. And then he talks about metadata management, but our documents don't exactly have much metadata, so we're not going to go through that right now, but you could read that. And he says that the standard, basically what we have, a corpora is a list, right? So we can apply lots of R functions, any R functions that you can apply to a list, you can apply to corpora. And he says specifically these can be applied. Now we don't even know what we know what this one is. And we don't know what all these other are. We never studied this one. And this one, actually, we never talked about it as a function, but it's actually, you can consider it as a function. But I'm not going to talk about that now. Okay, so let's do the main thing, and that is creating a term document matrix. So remember last week, I talked about turning something into a term document matrix or a document term matrix. Remember we talked about this last time? So that's the whole idea behind bag of words, right? And we said this last time. So we want to take the whole text and make it into a matrix. Do you remember? Remember we talked about this last week? So that's the whole idea behind what we call the vector space model or the bag of words. We need to make a matrix out of it. Okay, so we can do that with this single function. Okay, so let's do that and call it document term matrix DTM. Okay, so let's try. So the whole idea behind our approach to data mining is that one function, which is here. Okay, so let's do it. And now we have DTM. And let's first check what kind of object is DTM. So let's check the structure of DTM. Okay, check the structure. What is it? Okay, it's a list, which is kind of weird. So that's what it is. Okay, let's try the head. No. Can't do that. That doesn't work, okay. Okay, now let's try inspecting DTM. So let's do this. Now, let's remember, what is DTM? It's document term matrix. What does that stand for? We're going to have, let me make sure I get this right, yeah. We're going to have the documents down on as the rows and the terms as the columns. So in other words, we're going to have Reuters document number 1, Reuters number 2, Reuters 3, Reuters 4. We had a whole lot of Reuters documents, right? And then there are a whole lot of words in all of those Reuters documents. So what's going to go across the top here? What are going to be the columns? All the different words. For example, we might have the, we might have oil, we might have crude, we might have, what else? All these different words, right? And those are going to be the columns. Now, this is wrong. Why won't we have this? Because we removed the stop words, right? So the won't be in there. This is wrong. Why won't we have this? Because it's capital. We made them small, right? So it'll be like that. Okay, and so on. But anyway, we're going to have all those across the top, and then we're going to have the rows. Now, I guess it's pretty big. So what he does in his example is he says what? What does this do here? What?
It's pulling specific lines.
Yeah, a specific section of this matrix. Which section of this matrix?
5 to 10.
5 to 10 is for the
List. Oh, like a section.
the rows. Wait, should be the rows. Yeah, the rows. Rows. Is that right? Something's wrong there. And columns 740 to 743. Okay? So that's what we're going to be inspecting, so let's try that. Now I'm confused because docs 211 should be the, I would think it's docs 5 to 10, but it's not. And but the columns are what? These columns. Okay, okay. That I'm a little bit confused about why we're only getting, why this wouldn't be like 5, 6, 7, 8, 9, 10, and it's not. Let's try it. Let's try this. How about we change this to 50 to, or let's make it, sorry, Let's do 11 to 15. Let's try that. 11 to 15. Something's weird about that, isn't it? So the columns are still the same, but it's jumped. I'm a little confused. Maybe the documents are not, the documents are not in order, sorry.
There is no one. It starts at 127.
Okay, thank you. But even still, yeah, the documents are not in, there are missing documents, right? So that's, I guess, what's happening here. Okay? So we don't, let's check that. What are these Reuters documents? Let's see if we can find them. No. Let's check it. Well, I'm not sure why, but let's see, where's the ID? No, the ID.
So the second one.
What?
The ID on the second one.
Here, this is it. Okay, right. So it's getting the ID from here, it's getting the row number from here. Okay. Okay, so does everyone see what we've done though? We've, created our term document matrix. Okay? Now, sparsity, one word that they use in text mining is sparsity or sparse. Let's see if I can do this. Okay, so I did that. So what's that say? Dim DTM, what's that telling me? The dimensions of this matrix. So what are the dimensions? 20 by 1,000 something, right? So there are 20 rows, only 20 rows, that's not many rows, but there are 1,000 columns. Okay? So what,
The layers.
what?
Isn't that the layers? How many layers are on?
Is that true? I think it's,
That seemed like a better size.
right?
It would seem like a better size rather than the amount of rows.
Why, no, I mean, by the number of words, I mean how many columns there are.
Yeah, but it's more than 20 different words, isn't it?
No, columns, 1,027,
Ah, right.
right? 1,027. So there are 1,027 different words, okay? So, and there are only 20 rows, meaning 20 documents, okay? So why would we call, why would we describe this as a sparse matrix? Because here's row 1, and like here we're going to say, well, you can see right here, some of this is, there's a 2 here, there's a 2 here, there's a 1 here, there's 1 here, but look at here. There are no numbers here, there's no entries, right? By the way, what does the 2 mean? What occurred twice? The word published occurred twice in document with ID this, right? So what does the 0 mean? Means that the word published did not appear in this one, right? So basically, what do you expect mostly to get in this matrix? Zeros, right? And that's called sparse. The entries, the non-zero entries, are very rare, okay? In fact, their sparsity measure says that this was sparsity 83, and this, since they're all zeros, is sparsity what? 100%, okay? So Generally with text mining matrices, the sparsity is very high. And that means certain techniques don't work so well. But of course, text mining work, generally, our techniques are developed for high sparsity matrices, so they do work. Okay, so let's try a little bit more. Operations on term document matrices. So we have our term document matrix now. So what are some operations we can do? So what do you think this might do?
Looks like all the words that appear 5 times.
Yeah, all the words that occur, I think it's at least 5 times. At least 5 times. Okay? So let's try that. Or let's try it with, let's say 4 times. If I change this to 4, is the list going to be bigger or smaller? Bigger, right? So let's try that. Change it to 4. So find out all the words that occur at least 4 times. Wow, got a lot bigger. Okay? Let's try all the words that occur at least 6 times. Okay. So these are the words that occurred at least 6 times. So what can you, so if you look at these words, what does it tell you? Anything or nothing? Well, if you didn't know that this was about oil, then by doing this you will know that it's about oil, right? You can see that it's about petroleum and production and, right? You can see that it's about oil. Okay? So this helps you in that sense, and so this is useful. So find the most frequent terms, right? How about if we did it with 8? See what happens. Okay, now didn't get rid of also, right? Our stemmer didn't get rid of also, which is kind of annoying, right? Or our, I'm sorry, our, not our stemmer, our, what is it called? What did we want, what was it? That I should get rid of word also? Not the stemmer, but the, what was it called? The stop words. I would think that stop word also wouldn't be, also would be a stop word. So either I didn't apply it properly or something's wrong. But anyway, but except for that, or in fact, let's even do 10. I'm just curious, what will 10 give me? Okay. Okay, so you can see that it's about crude, barrels, and so on, right? Everyone see this? Okay, that's one. Operation we can do. Now this is an interesting one. Find associations with the word OPEC. So here we get these words that are related. I don't know, what do we mean by related, but the words that are related to OPEC are what? Meeting, emergency, oil, this, 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 this. So what does that mean? Shh. What does this mean? The words that are associated with the word OPEC. I think what it means, I'm not really sure, but I think what it means is if OPEC appears in a sentence, we want words that also appear in the same sentence. Or maybe it's in the same file, actually. So, and we want to have at least, no, that's not exactly what it means. It means, I'm not really sure what they mean. Find associations, terms which correlate, at least 80% correlation, but I'm not quite sure what he means by this. But anyway, it's words that occur frequently with OPEC. Okay? So these words, meeting, emergency, oil, analysts, inspires ability. Okay, so that can provide some kind of insight into the text. That's kind of a pretty cool tool, actually, if you're doing data mining. Okay, any questions so far? Okay, just a little bit more and we'll be finished with the discussion of this package, and then we will be able to study the R program that we have, which is here. Not there, sorry. Which is, where is it? Here, this one. Okay? So let's just do a little bit more. Or actually, before we, let's just get a peek of what we'll do next week instead. So we're going to study chapter 7. And we're going to, where is it? Down here. We're going to do some stuff like this next week. So now we've covered the TM package, so we should be able to follow what he does in his analysis of the movie taglines. So let's just quickly take a peek at that. We'll go back and do it in detail next time. Okay, so we saw the taglines already. And we'll build this graph, okay? But in order to build this graph, how are we going to do that? Because all we have is this weird file, right, that contains this kind of stuff. How are we going to do it? How are we going to build this graph? I mean, the meaning of this graph is obvious, right? What is it? How many movies were released each year? But how are you going to take this? How are you going to take this file and do that? That's all we have, is this file.
Let's do all the dates.
Yeah, but that's going to be hard to do. How are you going to get the date here and then the date here? That is not easy. Okay? Nobody, it's just this. This is all we have. Right? How are you going to get R to know that this is the date, and this is the date, and this is the date associated with this? It's going to be hard. Okay? But anyway, he does that so that he can show this graph. Okay? So that in itself is a big accomplishment. It seems like, oh, it's a simple graph, right? But it's an accomplishment. Okay, then, what's this? The bag of 200 words from 40 years. So 200 means probably the most frequent words. So he'll probably use what function for this? He'll probably use what we just saw, which was this one. Find frequent terms, right? Okay, so we don't know that for sure, but that's probably what he's going to do. And then, next, so what does this tell you anyway? Does this tell you anything about movies? Well, it tells you something, right? It tells you what people were doing. But actually what he wants to do really is he wants to look at differences over time. So this is not, I don't think this was differences over time, this was for all the 40 years. Okay, but he wants to look at different times and see if he can find out what's going on in different eras or different time intervals. Okay, now this is very interesting, and I explained this last time. And what is this again? This is called multi-dimensional scaling. But what does this tell me? That these two are close to each other. It means what in multi-dimensional scaling? What did I tell you last time? It means that these 2 years are kind of similar in terms of the words that were used in their taglines. Whereas, what does the fact that 2013 is really far away from this mean? means that these two words, these 2 years, are different in terms of the words that were used in the movie taglines. Okay, so that's a kind of a cool depiction of, or a cool analysis of these movie taglines. Okay, but how is he going to do this? Well, first of all, we don't know how to do multidimensional scaling, but even before we do multidimensional scaling, he's going to have to get all the words that are associated with this year separate from all the words that are associated with this year, separate from all the words that are associated with this year. Now that's going to be, that's a super hard task. Okay, that's hard. So you see the kinds of things we do in text mining, not so simple to start with text and have to get to this point. Okay? All right. By the way, this is actually going to be a label. This is going to be a label. This is going to be a label. So what he's going to do is he's going to store all of the words with the label of 2000, store all of the words with the label of 2007, and so on. Okay, so he does that. Now here's another technique. So here he has these so-called different dimensions. Now, dimensions we talk about, usually we think of 1 dimension, 2 dimensions, 3 dimensions, right? That's the normal. But we also talk about, in like psychology, they talk about different dimensions. Like we might have 1 dimension here is how much love you feel in your life, okay? Versus something about your work, how satisfied you feel in your work, okay? So you'd have 2 different psychological dimensions. It's like 2 different kind of concepts that you want to measure people on. So one is how much love do they feel in their life. Another is how much work satisfaction do they have. Another is what's their income. That would be normal. You know, that's an obviously numerical dimension. Okay, so here somehow he comes up with these different dimensions. Now, this is kind of a weird drawing because normally we'd only have at most 3 dimensions in a, you know, we're not used to seeing like more than that. But anyway, ignoring that, the dimensions he has are loved, story, life, truth, and worlds. Now, they're not very clear even what they mean, right? But what this picture is saying, regardless of whether they're clear or not, is that like 2009 was very high in the so-called truth dimension, whatever that means. So maybe that's like documentaries. Maybe what he meant by truth dimension is that there were a lot of documentaries that year, okay? Whereas 1982 didn't have a lot of documentaries maybe, but maybe it had love stories in it or something like that, okay? Whereas 2013, I don't know what this means. I don't know what he meant by worlds, okay? But maybe in 2013, this was strong in this dimension, okay? So we'll see about that later. And then we see this one. This is familiar to us. This is called what? A horizon plot, which, as I told you, probably not one of your professors knows what this is. People only came up with this visualization technique in the last 2-3 years maybe. So it's very new. And as I said, if you show it to any of your professors, they won't know what you're talking about. But you can explain it to them how to read it. But anyway, here we're doing it for loved, worlds, truth, life. So what we can see is, now I can't see the colors here, so I don't know if this is red or blue, but when we do it in R, we can see the colors, right? So let's suppose this was blue, very dark blue. That would mean what? That in this year, there were a lot of maybe love stories, okay? And in this year, there were a lot of worlds, and so truth, maybe, you know, okay? You can read it. We need the colors, actually, to read this. But doing this, we might gain some insight into what was happening in movies, okay? Now, creating all of this is hard work, okay? Taking that text data and somehow getting it so that we can do this kind of stuff is a lot of hard work. Okay? But we're going to use the TM package, which we just talked about. Okay? And that's all we have time for. Okay? So that's all for today. I think, so next time we'll finish up with